matrix and an inverse matrix is. Okay, so a little bit of background on this. The first thing that I want to look at is an identity means this, and you've talked about this before. I don't know if you've ever remember it being told this way. So it's real simple. The multiplicative identity, what do you multiply a number by that will always give the same thing back? 1, right? That's what we mean by the multiplicative identity. That's just 1. So A times 1 is A. Okay? Same thing down here. This is all the same down here. 3 times 1 is 3. 3/4 times 1 is 3/4. Negative 2 times 1 is negative 2. So we call that number 1 the multiplicative identity because it makes it give back the same identical thing when you multiply by 1. That's the idea. Well, what we're going to look at, since we're talking about matrices, is we're going to look at an identity matrix. And I'll talk a little bit about how an identity matrix goes. So the idea is this is a matrix. And I'm going to write that like that. If you multiply by the identity matrix, you should get that same matrix back. Okay, for the same reason. And if you did this backwards, if you took the identity matrix times any matrix A, you should get that same thing back. Okay, so what we're going to learn is what does an identity matrix look like and how does that multiplication work? Okay, so that's what we mean by an identity, a multiplicative identity. All right, so one thing that we want to kind of get straight on here is an identity matrix has to be a square matrix. So you can't have anything other than like a 1 by 1, a 2 by 2, a 3 by 3, 4 by 4, 5 by 5, and so forth. Identity matrix always have that look to them. Okay, so the way it's going to look is like this. All right, so basically all of these are square matrices, so they would have an identity that goes along with it then. Okay. And I'm going to show you what they are on this. I want you to just write this in. The identity matrix for a 1 by 1 is just 1. Okay, but it's a little bit different for the other ones. The next one goes like this. If you have a 2 by 2, the identity matrix is going to go like this. You're going to have a diagonal of 1s and a diagonal of 0s. Okay, we'll see why that works here in just a minute. If you have a 3 by 3, then the identity goes like this. You'll have a diagonal of 1s. Everything else is going to be a 0. So what you're going to find on this is this. If you took this 2 by 2 times that 2 by 2, you would get the same thing back. If you took that 3 by 3 times that, did it by hand or in a calculator, you would get the same thing back. So you're always going to have a diagonal of 1s. Everything else is a 0. That's what we call an identity matrix. Everybody understand what I'm saying there? Okay, so you want to understand that it's a square matrix with that diagonal of 1s. Okay? Okay, so I've written this on this page, so this would be what the different identity matrices look like. They all have that diagonal of 1s. That's the idea. Okay, so we're going to do one of these, a couple of these, I guess, by hand. And this kind of thing right there, you should know what the answer is. But we're going to go ahead and just do one of these by hand. Okay, this is a 2 by 2 matrix. You're multiplying by a 2 by 2. So we can do it. So what's the size of the answer? 2 by 2, right? Okay, we've talked about that today. So we're going to do this, and we're going to fill this out, and I'll show you what happens. And if you're catching on what I'm talking about, you won't be surprised what the answer is, okay? So I'm going to do this then. I'm going to write out the steps. You're doing that row times that column first. So what you're doing is 2 times 1 plus negative 1 times 0. That's the first calculation you do. So that's going to be 2 plus 0, so that's equal to 2. So that's what goes there. Notice it's the same thing, okay? And then we go to the next thing. We just go to the next column. So we'll do this. I'm going to do 2 times 0 plus negative 1 times 1. So that's 0 minus 1. So that is negative 1. Same thing. Okay, that's what you'd expect to happen on this. Okay. Then what we got to do is we go with the second row and the first column. So we do that like we've learned. So we're going to do 3 times 0 plus, 3 times 1 plus negative 2 times 0. That's 3 plus 0, so that's equal to 3. So notice you got the same thing back. Are you convinced yet?
Nope.
You're not convinced, okay? Okay, so one more. We do 3 times 0 plus negative 2 times 1. So that's 0 minus 2, so that's negative 2. So it'll always work. So I mean, actually, in all of these problems that I've got on this page, you can tell me what the answer is in your head, and I want you to know that, okay? And it doesn't matter what order you do these in. So what's the answer to this one? The second matrix, right? Okay, so the answer, without working it out, is going to be 1, negative 1, negative 2, 3, because that is an identity matrix, so it just has the effect of multiplying by an identity, keeps that original matrix the same, okay? The answer to this, we're not going to do this by hand. It takes too much of our time. This is an identity matrix there, so the answer is the first matrix. So if you see something like that on your homework, don't even take the time to work it out. Okay, you want to know what the answer to that is automatically. Don't waste your time, okay? All right, everybody with me, okay? Okay, so just know what the different identity matrices look like. All you got to remember is a diagonal of 1, everything else is a 0. Okay, and this is what happens when you multiply. Okay, so these right here, I'm not going to have you do these any other way except just write the answer. Okay, all right.
Is there a way to write first and second matrix without writing the entire matrix?
No, not really. No, you really got to write the matrices out, so you do that. Okay. So again, when you see this on your homework, just write the answer. Okay, unless you want to, unless you're not convinced yet of what the answer is going to be. Okay, so again, I'm just multiplying by an identity matrix. Doesn't matter which order you do it in. So this first one, that would be the answer. The second one would be the second matrix, like that. All right, everybody clear on what I'm doing there? Okay, all right, so that's real easy. Okay, now I'm going to talk just a little bit about an inverse, just kind of get the idea going today, just at least get the idea going. And then when I have you do an inverse, most of the time you're going to do that on your calculator. I'm going to teach you how to do a 2x2 inverse on the without a calculator, though. Okay, so here's what happens. This is what a multiplicative inverse is. So let me ask the question to you this way. Okay, and you don't need to write this down. What would you multiply 2/3 by to get 1? Well, like 3 over 2, right? So the multiplicative inverse is a reciprocal. Anytime you multiply a fraction by its reciprocal, you get 1, don't you? Because that's 6 over 6, so that's 1. So that's what that is. So what you would have on this is the reciprocal of a over 1 is 1 over a. Okay, that's what we call the multiplicative inverse. Okay, the next one you have 6 over 1. So if you multiply 6 by 1, 6, you should get 1. Okay, same thing on this next one. Negative 1 over 1, if you turn it upside down, you still get negative 1. Okay, and then the next one, 3/5, turn it upside down, that would be 5/3. So that's what we mean by a multiplicative inverse. It just means you take a number times its reciprocal, you will always get 1. So in general, a times 1 over a is going to be 1. Okay? And I don't want to do anything with matrices today. I want you to just simply fill out these 5 problems, and then we'll call it a day. Okay? These are just, I just want to make sure you understand what a multiplicative inverse is before we even touch the matrices that we'll do next time. Number 5. Okay, so what did you put in the first blank? Nothing? That's what I thought. What do you do to, what do you multiply a number by to turn it into 1? What do you call that when you turn it upside down? The reciprocal. Okay, so that is the reciprocal. Okay, the rest of these are pretty simple. The multiplicative inverse of 10 is 1/10, because 10 times a tenth is 1. The multiplicative inverse of -5 is -1/5. It doesn't matter where you have the negative, because if you multiply that out, you get 1. Multiplicative inverse of 1/6 is 6, because 6 times 6 is 1. And then the next one would be -7/3. You do that. So it is a reciprocal. What do you think the multiplicative inverse of 0/1 would be? You can't do it, so there's none. Okay, so if you turn that upside down, you get 1/0, so it's undefined. So that is what we mean by an inverse. Okay, all right, so we'll wrap this up next time. I'll bring you 4/6 too. I'm going to print that out because I'm going to make some changes on that.